Hi everyone, this is the 10th video in the algebra series and I'm covering section 10.85, which is complex numbers. So let's start with the main concept of complex numbers, which is I, it stands for imaginary numbers, is equal to rad -1. So as you see, I can figure out I squared, which is -1, and also I to power of 3, which is I to power of 2 times I, which is -1 times I, which is -I. You can also find other combination of I as well. So let's do one more time. I to power of 4, which is I to power of 3 times I. We know I to power of 3 is -I, so this is equals -I multiplied by I, which is -I squared. As you see, I squared equals -1, so -I squared is equal +1. Let's take a look at graphical representation of imaginary numbers. So I'm gonna use the same, pretty similar coordinate system, but the only difference is this is my real number axis and this is my imaginary number axis. For example, the number a plus bi. So this is a unit on real number axis, and this is b unit on imaginary number axis. So this is my point on this type of coordinate system. So now let's take a look at a couple examples. Example number 1. We have -rad20 plus rad -5. I wanted to see what is the result. As you see, 20 is 4 times 5, and 4 comes out, and I'm going to be left out with 2 rad -5 plus rad -5. So it is equals 3 rad -5. And as you see, I can show -5 as -1 times 5. So I can show the whole thing as 3 rad 5 times -1, and we know 3 rad -1 is I, so I can replace the whole thing with 3 rad 5 I. This is the answer right here. So you're just going to pay attention and make sure you are keeping the I, which is your imaginary number, aside, and don't mix it up with your real numbers. So the second example would be just addition of real numbers and imaginary numbers. I'm gonna have 7 plus 3i minus parentheses -2 plus 4i, which is equal to 9 minus I. This is actually pretty simple, so I'm going to go over this one more time. As you see, I have 7 right here and minus -2, which is 7 plus 2, so I'm gonna have a 9 here, which was pretty obvious. But we do the same thing for imaginary numbers. Plus 3 minus 4i, so it's going to be negative 1i. So let's move on to the last example, which I believe is the most important one. So what I am going to do is basically simplify this fraction. 7 plus 3i divided by negative 2 plus 4i. So the main concept is don't have any imaginary numbers in my denominator. So I multiply the whole thing by the conjugate, which is negative 2 minus 4i divided by negative 2 minus 4i. The denominator is going to be a squared minus b squared, which is negative 2 to the power of 2 minus 4i to the power of 2. And on the numerator, I'm going to have 7 plus 3i multiplied by negative 2 minus 4i. So now let's simplify this. I'm going to start with the denominator first. I'm going to have 4 right here minus 16i squared. As you see, I squared equals negative 1. So negative 16 times negative 1 is going to be plus 16. So the denominator is going to be 20. The numerator, let's develop this. 7 times negative 2, which is negative 14. 7 times negative 4i, which is negative 28i. 3 times negative 2, it's going to be negative 6i. And then negative 12i squared. So now let's simplify the whole thing. As you see, I have negative 28i right here and negative 6i right here. So it's going to be negative 34i. I have negative 14 right here and 12i squared. As you see, I squared is equal to negative 1. So it's going to be negative 14 plus 12, which is minus 2. So now let's simplify the whole thing. Divide both numerator and denominator by 2. I'm gonna be left out with negative 17i divided by 10 minus 2 divided by 20, or 1 divided by 10. Again, thanks for watching our videos. I'm going to post a Google Drive account on the first comment. Make sure to take a look at it for more examples, notes, and lectures. Have a good one.